talked about integers. Today we're going to take it a step further and introduce rational numbers. A rational number defined is any number that can be written as a fraction, which means that now we would include fractions and we would include decimals. All rational numbers can be plotted or graphed on a number line. These are examples of rational numbers. We're going to plot those in just a minute. Let's look at this diagram to help us understand the difference in the numbers we know about. Whole numbers are numbers that would fit inside the triangle. Integers are numbers that would fit inside the oval. And rational numbers would fit inside the rectangle. So if I put the number 3 here, it's because it's a whole number. And because it's inside the oval, it's also an integer. And because it's inside the square, it is also a rational number. -6 is a good example for here because it's not a whole number, but it is an integer and it is a rational number. And today we're going to talk about numbers that have something after them. Rational numbers are numbers with decimals, fractions, because we know that you can convert all fractions to decimals. So how do you plot them? Well, this is 3. And if this were my number line, I would need to pick something that 3 comes between. So I could say that this is 4, and this is 2. And if I ask you to plot 3, well, I know that 3 comes between 2 and 4. Now I have to plot -2 and 1/4. 2 and 1/4 comes between -2 and -3. So my number line might look like this: -2, -3, -4. And -2 and 1/4 would be closer to -2 than it would be -3. -7 and 5/6. -7 and 5/6 is going to come between -7 and -8. So if this is -7, then this would be -8. And I know that this would be closer to -8 than it would be to -7. 23.7. 23.7 would come between 23 and 24. 23 and 24. And 0.7 is more than halfway past 23. So it would be closer to 24. So to graph a rational number, pick 2 numbers you know it comes between and plot it on your number line. You know that opposites, 2 and -2, are opposites because they are the same distance from 0. Well, today we're going to learn about absolute value, and I've used absolute value in this black sentence. Opposites, 2 and -2, are opposites because they have the same absolute value. If I read the sentence in green and the sentence in black, they're identical with the exception of this and this. So if I reread these sentences, I could switch these because they mean the same. So from this sentence, because they are the same distance from 0, because they have the same absolute value, I know that absolute value of a number is the number's distance from 0. So however far away you are from 0 is your absolute value. Absolute value is written in math with straight lines surrounding the number. So I might say, what is the absolute value of -8? And you know that absolute value is how far away from 0 it is. Well, how far away is 8? It is 1, 2, 3, 4, 5, 6, 7, 8 away. The absolute value of -8 is 8. Let's find the absolute value of our numbers here. The absolute value of 5 is 1, 2, 3, 4, 5, because it is 5 away from 0. The absolute value of 9/2 is 9 Because 9/2 is that far away from 0. How far away is -3 from 0? -3 is 3 away from 0. How far away is -1? It is 1 away from 0. How far away is -1.7? Well, it is 1.7 away. And how far away is 23? 23. What's that you notice about the numbers in blue? All of our absolute values are positive. And that's because absolute value is always positive because distance is never negative. No one ever drives -3 miles because no one ever walks -12 feet. Distance is always positive. So, let's take what we know about comparing integers and now what we've learned about absolute value and figure out which one of these has a greater value. Our first one says, which is larger, the absolute value of -2 or 5? The absolute value of -2 is 2, and 5 is 5. So we would say that the absolute value of -2 is less than 5. Well, what about the absolute value of -6 compared to 3.1? The absolute value of -6 is 6. 3.1 is 3.1. And 6 is greater than 3.1, so the absolute value of -6 is greater than 3.1. Here they're asking you to compare 4/5 to the absolute value of 9/10. The absolute value of 9/10 is 9/10, and 4/5 is 4/5, and 4/5 is less than 9/10. Here it's asking you to order these from least to greatest. So let's rewrite the numbers that we are to order. -9, the absolute value of -6, which is 6, 4.5, and the absolute value of 7, which is 7. And now they want us to order these from least to greatest, remembering left is least. So on my number line, if this was 0, -9 would be here, 4.5, 6, and 7. And so this would be them ordered from least to greatest. This is where you'll push pause and solve these problems. Circle the animal that's the deepest, the animal that is the furthest down into the ocean, the furthest below sea level. Below sea level is represented by negative numbers, and 65 has the largest absolute value, which means it's the furthest from 0. So we're going to circle the shark, the shrimp, Underline the elevations that are not represented by an integer. Here are elevations, and the ones that are not integers are the ones that have fractions as part of their number. The ones that are not whole numbers or their opposites. And you can tell that I did not read the directions, so you should have underlined 56.5, not circled it. All right, which scientist went furthest underground? Which of these scientists is furthest from 0? Who went furthest? The absolute value is 62, which is the furthest, which is B. And then finally, write the absolute value of -4.5. So you have 4.5. The absolute value of 27 is 27. And the absolute value of -3/4, 3/4. And you can tell I've made this video 3 times. I skipped it on this one. So let's go back up and do this one. Use a number line to graph the elevation of the turtle. The turtle is negative 22 and 2/5, which means that I have to choose two numbers that it comes between. The integers that this comes between are negative 23 and negative 22. And negative 22 and 2/5 is almost halfway between those. So I will be plotting it here on this number line.